Very good evening. Good evening to everyone. Am I audible?
Yes, Lakshmikant, you're audible.
That's really great. We'll just start in a couple of minutes. Okay. Meanwhile, just check it out. I'll just share you the responses. Okay. Okay. Yesterday, I think 53 people have filled it. Just check it out, guys. That is 39% are from 2024, 28, 2023, 2022, 26. So many, right? This is the response. And placement status, 81% of them didn't get internship, 7%. Sorry, 13 job offer, 3%. There are so many things like this. Okay. And many people know hacker rank, many know lead code, all those things. These are technologies which many people are aware. Cool. Okay, that's really great. And if you really see, like, say, these are the things: soft skills, algorithms, coding. This is something which everyone wants to improve. And some communication skills: React, Node.js, Flutter, so many things. And I got response saying that they want to know the fundamental knowledge. So basically, the sorting, searching, all the fundamental things will be there, which will help you to get a job. Basics to advanced level, yeah, definitely definitely try to cover the advanced algorithms, but in 16 hours, whatever possible, will do, keeping freshers like non-CS background in mind. So data structure algorithms, yes, this is from scratch. React, Flutter, okay, it's very nice. Hackathon, okay, that's all good. And I think one more thing I was expecting. Yeah, this is something which I've received. Please feel free to fill it. Okay. Okay. Welcome all. So we'll just revise. Cool. So what we learned yesterday? We learned what are the programming concepts and principles, like generally syntax, data types, variables, scopes, operators, control structures, functions and methods, object-oriented programming, input, output, error handling. These are something which are majorly available, or like these are the concepts of most of the programs. Okay, programming languages basically. Now, then we started with programming with Java. Okay, then we started with like operators, Java operators, arithmetic, relational, logical, assignment, increment, decrement, conditional operator, basically ternary operator, right? Then we moved on to control structures. Control structure, why we need to make some decision making like if statement or if else kind of things, switch statement, while loop, do while loop, for loop, for each loop, continue, break. These are the control structures. So this helps us make some decisions. Then some basics of arrays and strings. Today we'll continue on arrays and strings, and we'll go more on programs which are mostly asked in interviews for freshers who are from non CS background. Okay. Now, so let's begin. Okay. uh, so algorithms. Okay, for those who are even not getting anything, just algorithm means what? It's a step-by-step procedure, or some set of rules are defined to perform some specific task or to solve a particular problem. For example, let's say I want to book a Uber, right? There are step procedures, right? Just select first from to location, then next step would be s- type of vehicle, then route selection if you wanted, then book the vehicle, payment selection, you want to pay later or pay now. This is some of the task, right? Then book a cab, This is generally, you want to do this, we'll have algorithms. Clear? This should be relevant to you all, correct? Oh no, the current form which I have shared, it's not compulsory. Okay, cool. So what are the characteristics of algorithm, right? So what algorithm needs? It needs input and it gives you output. So let's take Uber example. It needs input like, okay, from to our input. It provides output means it gives you the Uber vehicle. That's the output. So something like this. Define definiteness. Definiteness means what? There should be end to it. Each step should be defined. When I book a cab, I know, okay, from where I'm going to, like from and to destinations. Okay. Finiteness. Definitely after a certain time, it should end, right? Even when you write an algorithm or, for example, sorting, searching, it has to end after a certain amount of step. Effectiveness. Effectiveness, every operation must be basic and can be done exactly. Okay, let's say you want to go from one place to other place using Uber. If I write algorithm which takes 100 kilometer rather than 10 kilometer, takes some wrong route, then the algorithm is not effective. It should reach in a short time, right? Okay, and then consume less, like kind of a road which is short duration, something like a lot of parameters matter, correct? Cool. Okay, now we have something called as pseudocode. Pseudocode means step by step writing, like what kind of steps I need to write for this algorithm. Let's say, for example, if you want to do bubble sort. Okay, what is bubble sort? Bubble sort means sorting an array. Example. Okay, so what it needs input, which is array of integers here in the example. Then what I do next step is, okay, how many are there? That's when I get length. I need to know the length to sort it. Then next step, next would be writing a loop. Okay, iterate through from 0th index to last index, right? Because array start from 0, I make 0 to n minus 1. Then there is one more loop, because it is bubble sort, I have to sort from largest to, like I have to sort from one by one. So it's a n square thing. Then when I come to the inner part, I compare j with j plus 1. It means first index to next index, then alternative index, as long as I meet the criteria, being the largest is pushed to the last in the array. Okay, swapping them, and then end if loop. If this condition satisfied, then end inner for loop and outer for loop. When this loop runs up to n times, then both the loops are terminated. It is big of n square algorithm time complexity. Let's just see this here. Okay, here you'll understand the real use case, right? Or like animation. Let's say this is array means at 0th index I have 23, at first index I have 2, at second index I have 27, 47, so and so. I want to sort this. Clear? So what first I do, I'll compare with 23 with 2. I see that 23 is greater than 22, so what I do, I swap them. Then I compare 23 with 27, but 23 is smaller, so I don't swap. Then I'll just go to next. I compare 27 with 47. I see that 47 is larger. Then again, I don't swap. Then again, I compare with 47 with 38, which is at index 3 and 4. What I do? I swap them. Then again, 47 with 50? No, because 50 is greater. Then again, 50 with 27. Yes, I got to know that, okay, 27 is smaller. Then again, I sort it the same way. Because 50 is largest, okay, this is inner loop. I mean, the first inside loop, right? So after first iteration, inner loop, at the last index, I get the largest element. Okay. From the next iteration onwards, I don't go till 9. I go up to 8th index only. Just check it here. So compared, it went done. Next, like this, keep on doing. Okay. So this fourth iteration, fifth iteration, sixth, seventh. Okay, like this. today. Those who are on, or remind muting yourself.
Lakshmikant, please unmute yourself.
Oh
No,
my
no,
God.
now only I off it. No need to worry.
You muted me?
Yeah, no, no, actually, it's extra sounds are coming. No, that's why I did that.
Okay, okay. I was like confused suddenly.
No,
Okay, okay. I muted that person basically. Anyways, okay. Just check it out, guys. I have shared this visual algo.net. You people can just check it out. Just go here. This is bubble sort. So this sorting searching will do it next week. But one small thing you can choose. You can restart this and keep on checking. Otherwise, just play it. It will automatically happen. You can see the simulation. What's happening here? It's easier to compare. Clear? If I want, I can create array also. I can create array like this here. Then if I click go, automatically you are not between 0 to 50. Okay. We should insert between 0 to 50 here. Then if I sort, see custom inputs also, just check this comparison. So based on our pseudocode, the same way the algorithm sorts. Clear? I hope everyone understood this. This visualizing yourself is really required. Okay. I can see few people. I remember few people name from yesterday's class though. Clear. See, I'm expressing explaining this considering non-CS background, like how sorting happens, how things happen, what is algorithm, all those things, keeping in non-IT background. Okay. Now, you people might have heard like, okay, time complexity, space complexity. What is complexity, right? So imagine you have like thousands of books, right? Librarian comes and says, "Hey, sort it according to shelf." Okay, what do? You go and right, you try to do some algorithm. Or if you are there, okay, imagine what they want. There are only 10 racks, right? So okay, let's consider 26, right? Alphabets, okay, whatever. So in first track, A to D or something like that, they'll divide. So what do? Whenever you get A, you'll pass it on to first person. Whenever you get something like Z, you'll pass it on to last track. Right? That's how you sort it. Why sorting is required? Because I want to search it really quick. Right? That's when to do this, the complexity analysis matters. Right? Okay. What is algorithm complexity analysis? It means measuring the efficiency of an algorithm in terms of time and space. For example, if I use this algorithm, do I get the output very fast? Do I consume the memory or like space less? That's what matters, right? If someone asks you, okay, explain algorithm complexity, you can say it is it's the efficiency of an algorithm in terms of time and space, right? How the complexity is measured in terms of time and space, how efficient algorithm is. Okay. Now, what are the factors? Time complexity, space complexity means, see, above line, below line, the difference is based on the input size, the runtime changes. Runtime means if I have, okay, I'll give you 100 boxes, I'll ask you to sort, it's easy to sort because you can just quickly do. If I give you 10,000, 100,000, it's really difficult to sort. That is time complexity based on the input size. Even space complexity grows based on the input size. For example, imagine you are given like only okay 10 gallon of water or something. You need to have, you take less amount of water to shift it, right? Just imagine okay, let's take a realistic example. You are living in some Marthalli or something. If you are from Bangalore, okay, suddenly there is no water. So how efficiently you transport the water, that matters, right? That's called space, like water tanks, all those things. And in a very efficient manner, the time should be taken like less, right? How do you transfer? Oh, do we need to go into less like time consuming area? That's all matters. Cool. So things are relatable, right? So sorting, searching, space. So we need to take less space, but we should deliver it. Like let's say this Zomato people or someone, right? They have this box, the bag at the end, right? They might go instantly deliver 4 to 5 people based on the route. Though they save the space as well as time rather than going and coming, right? To and fro, right? That's a realistic example. Okay. So generally there are three things like I said no omega, theta, and big O notation. Generally, big O is a worst case complexity. Worst means more than this, nothing can happen. Right? It describes upper bound of the growth rate of an algorithm. Upper bound means there are like three: upper, middle, lower. Lower, it's okay. Smaller one, I don't care. Worst case, I want. So that's why upper bound of time complexity. So based on the input size, which takes most, that's what big O calculates. Okay. So these are the common big O classes. O of one means constant space, constant time. Constant time means it's always same. Irrespective of anything, it's always same. So if someone says, uh, okay, imagine the distance from one place to other place is 10 kilometer. Irrespective of anything, if someone asks you, okay, gives you a vehicle which is average speed is 50 kilometer per hour. Whoever goes, how many times you want to go, but the time is space same, right? It's always fixed. That is constant time. Same time will take. It will not vary. Okay. Now next, logarithmic time. Okay, for logarithmic time, let's assume you have a dictionary. Okay, I'll ask you, hey, just get me something from alphabet, yeah, H. So what I do generally, I'll either start from scratch, starting, or I take the middle and I do it, divide it, right? So logarithm means like take the input. If there are 10, first half, second half, I'll consider. Then again, divide it by first half, and in the first half again divide by 2, divide by 2. So if I go it like divide the inputs by 2, then it becomes logarithmic. We'll explain this with respect to code, how log n matters. Okay. Linear time. Linear time, let's say someone is given you there are 10 boxes. They'll ask you, hey, tell me which box contains fruits. Okay. If you start searching from the box 1 up to n, it'll take n times, right? 1 to n. It could be in first, it could be in last. If it's in first, it's I got it at the first instance only. If it's 10th, then I got the last instance. Upper bound is 10, lower bound is 1, middle is 5. So worst case is I can get at end at the 10th position. Clear? Are you able to follow me this time complexity, how I'm trying to relate? Non-CS background, CS people might get it easily, but non-CS, space and time complexity generally asked in mass recruitment, like, or campus recruitment. Are you getting it? People can respond. Okay, great, at least one said. Okay. Linear arithmetic time and log n, quadratic cubic time. So this is also examples are there. I'll explain more in detail, okay, in coming time. So n square means iterating like over an array. So you could see in bubble sort, I iterated in multiple times. For example, like there were n. Okay, I'll just show you. If there are 5 items, for every outer loop, inner loop runs 5 times at least. Okay, something like that. That's a n square thing for the bubble sort. Cool. So like this, we'll have more algorithms, and on that I'll explain in the coming classes. Now let's come to space complexity. Space, I told, right, what amount of space it takes to do the algorithm, right? So it measures the amount of memory space an algorithm uses based on input size, based on the input. Right? If I give 10, like if I, okay, let's say I go to a kid and I'll hand over some notes of 5 rupees, 10 rupees, 50 rupees, 100 rupees. I'll say, hey, sort it. If I give you only 100, it'll be easy, no? He'll spread across all the room. He'll take 5 rupees one and 10 rupees, 50 rupees, and something. It's easier. If I give 10,000, oh, space is less, right? Only room becomes less for the kid. Getting it? Space complexity. I go to a kid, I ask, okay, sort it, just for a fun. But if you give less, then it's easy to sort. Linear means it's just like I told you know, one from one place to other place, like end. Linear search. Linear means if there are n times, I'll do computation. That's a linear algorithm. Clear, Amit? Okay. Linear space means, imagine I'll say, hey, there are 10 cans, each can of 1 liter. I want to fill it. So if there are n cans, I need n space. If I ask 100 liters, I need 100 cans. If I ask 1,000 liter, I need 1,000 cans of each 1 liter. That's a how much I demand that space I need to do that. Quadratic means, okay, what happens? Imagine like 2D array. If I have two-dimensional array, I need to make it n square space, like n square space I need. If I have, I say two-dimensional array of n, like 3 row 3 column means I need 3 square. If I say four-dimensional array, 4 into 4 dimensional array, then n is 4, then 16 spaces. 5 means 25 space. That's a big O of n square. Okay. A real example I'm thinking what it could be. Tuk, 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 tuk. N square. Yeah, two-dimensional array is one. Hmm. Okay, let's just I'll explain more maybe in Monday's class. Okay, O of n algorithm, right? Array. So creation of array of length n. Okay, time and space complexity. Any doubts here? This is mostly asked in interview because yesterday someone asked, no, which are the things which are focused in interview? Time complexity, space complexity. Based on, they'll give you algorithm. They'll ask, hey, let me know what's the time complexity of this. Any queries? Okay, one person said clear. Any other? Anyone from YouTube? Because time and space complexity is basis for everything. Algorithm. Let me just check YouTube. Anything is there? I don't see any queries here. Okay. Okay, fine. So let's go to the next one. So these are the some of the real world examples of algorithm analysis. So sorting algorithms, right? So every algorithm has different sorting algorithm. Time complexity. Quick sort has n log n, bubble sort n square, right? Then in search algorithm we have binary search which is n, log n, linear search n. Graph algorithm we have, graph means I told you, right? So for example, there is a postman who wants to deliver all the posts, so he has to take, or like food delivery by whatever. So depth first search, breadth first search, this is also graph algorithms. We have different complexities. Next, see, just take any example where you can calculate the time complexity and space complexity. I'll just give you one simple example. You people can let me know. Okay. I'll just tell you. Wait, let me just share complete one. Okay, if I say, okay, one more concept I'll explain. Methods, yesterday I told methods are something which are reusable, right? Reusable things are methods. Clear? So I want to say sort, public void sort. How do we create? So we need to make static method. Don't worry about this much. Okay. If I ask you to sort this, okay, here, and when I print, should be like 2 4 1 5 7 7 1 3. Or let's just make one more simple method. Let's say search. Okay, in searching I'll ask, so I need to print whether 4 is there in the element or not. Okay. Can someone quickly just tell me what is the time complexity I can take in sort and search? I'll just give you this. You people can try this out. Hmm? Can someone tell me what is the time complexity for screen is not visible? Oh, really? I'm sorry. Can you see now? Can you see now? Okay, great. So just imagine this is a Java class. Okay. So can you tell me the time complexity of the sort and search here? Already shared here. Can you quickly tell me what could be the time complexity here if I sort and search? Any sorting? Anything? If you remember bubble sort also, I'm good. Not getting? No answers? I'm just waiting for answers. And 96 peoples. Okay, anyone from here? You do? Okay, 2 4 13. Search will be constant linear time complexity. Okay, cool. What about sort? Are you sure we can have it linear only here? Can I have some others type? Okay. Basically, searching means what I'll do is I'll iterate through. I'll just write here for int I equal to 0, I less than length. Okay, I plus plus. What I'll do, I'll do what if search item, right? If I get it somewhere, I'll say at index. I'll just print I. Cool. If not, okay, and then I'll write return. Just don't worry about return. I'm just coming out of this function. Otherwise, item not found or number not found. I can say. Cool. Let's just simply try search one. Number found at index 2. It means how many times this for loop ran? Maximum it runs n times from 0 to n. So it means it has time complexity of n. Correct? N means length of array. N, which is here space. I'm not using anything because I'm just using one variable to compare. It's just big of 1. Okay, space complexity, time complexity is big of n. Here, okay, just to prove this, let's just say I wanted to search number 13. I'll just put a debugger here. I'll try to debug this. I'll just show you how many times it runs. So as there are 5 items, maximum worst case it has to run at least 5 times, right? Let's just check here. Okay, first time, second time, third, 4, 5. Done. 5 times it ran means length of array n times. If I give 100, if I give n items, then it will run n times. If I give 5 items, it will run 5 times. So time complexity is O of n. Space is, I'm not utilizing any other space. Single one comparison I'm doing. So it's just constant space. Clear? Any non CS background? Did you try understanding this debugging thing? Clear? Okay. Is it something like very like interesting, or is this approach not understandable? Okay, only one person is responding. Okay, clear. So next, let's say sort. Can someone quickly give me a code of sort if you remember? Confusing. Okay. Simple. Imagine I want to search a number. So what I'll do, I'll start from here. I'll search with 0th index, then I'll come here, then I'll come here, then I'll come here, and I'll search. So if there are 5 items, maximum worst case is 5. Imagine I wanted to search 23. Worst case, how much comparison I'll do? 1, 2, 3, 4, 5. Where is the comparison done? Here. How many times this loop will run? Array dot length. If imagine if I have 5 more items or like something like this, how many items are there? If I have n items, how many times it loop will run? N times. That's a time complexity. N times it will run. Clear? Okay, great. So basically just practice this. Time complexity is not that difficult. Okay. If I have multiple like 10 numbers, maximum is 10 times. But if I give 2, then it will run. Let's just debug again. So let's see how many times this loop runs. Okay, once, done. It ran only once. It came out. Because this is the best case. My number is present at the 0th index. Okay. If I give something 4, Then let's see how many times it runs. Okay, once, twice, thrice. Okay, out of 5 times, 3 times, almost middle, average case. Okay, if I give something like 44, if I try to run this, what will happen? One, two, three, four, five. After even fifth iteration, also after checking all the 5 items, it couldn't find the search item. That's when it came out. It said, "Hey, no, boss, I didn't get it." It means worst case is how many elements are there that many times. Now clear? Cool. So let's just say sort. Sort means what? What I'll do? I'll just take for loop and I equal to 0. Same, right? Bubble sort. Let's just copy from here. Let's just take the bubble sort. Okay, I think I might have written here somewhere, no? No, 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 no. No. Okay, anyway, let me just try it. Next one iteration is j. J is less than array length. So j, I'll start from 0 only, but array length minus of I because I want to compare the last one. Then j plus plus. What I'll do is swap it if array of j is greater than array of j plus 1. Yesterday we did it, but I'm just doing it quickly. Okay. Anyone has the code program? Okay, I'll send that. I'll send that. Anyone has a code here? No one. If it is greater, what I'll do, I'll swap it. So what I'll do in temp number equal to array of j, then put array of j plus one value into this, then in array of put array of after sorting, what we can do, we can just compare it. Let's write int k equal to 0, k is less than k dot length, k plus plus. Okay, array of print it using system.out.println. Clear? Okay, let's try to run this and see. Let me just comment out search part. What's that thing? Bucket, bucket, bucket. What is this? Index auto form. Something somewhere I missed it. Array length minus I plus 1. Okay. G plus plus. Something I might have done mistake here. What is bubble sort? Air length plus 1. Okay, if you really want to debug, we can just do it here. Okay, I'll just show you. See. Okay, it went somewhere. Something I'm doing wrong. J is greater than j plus 1, then I'm trying to swap that's there. G. Can anyone find the error? Okay, g minus I plus 1. I think I need to do minus 1. Okay, there was something. Okay, after that. Oh, again some mistake. I need to replace the temp. Okay, clear. But this runs n square time. This is the time complexity of n square. Okay. Cool. Let me just share this program. Hmm, By doing it. What I'll do is I'll give you the GitHub link where you people can. Okay, j plus I is greater than j plus 1. Okay. Something is different. Someone gave the answer. So I'll just try to push this code in the GitHub. I'll give you the link. You people can just check it. For example, let's say GitHub link. I'll just show you. Okay. In this, if you go here, you'll get all the programs under this. Hmm? Same way, if you just check D3, I'll push all the programs under this. Okay. People can explore more. Hmm? Just check out like this and see the code inside this. Or they just okay. Check this out. Everyone can access the code here. Day one, day two, day three. All the days things will be available. Cool. Okay. Now we have just explored the basics of this. Okay. I have also shown you how we can write methods. If I want to write method, I just need to write something like this: public static void sort, and then pass the parameter. We can write it. Okay. Okay. Now, now let's just go to the next topic, which is data structures. Once again, just let's take a small break. But if you have any queries, you can ask here. Anything. Just explore this GitHub. You will get a lot of code there. Yeah, yeah. Ashish sent array of j plus 1 equal to temp. Yes, man. Sometimes we forget. Thank you. So, any queries? Anything here? Any doubts in this? Time complexity, space complexity matters a lot. Okay. So, all those who are on YouTube also, good evening to you all, and hi to everyone. So, why data structure is important? We'll explore now. Okay. Just 2 minutes break will take. No queries from here. Everyone understood? Okay, I'll just ask the people who generally ask questions like Mamta, Gurudevi, Vaishnavi, Anjali, and there used to be some other person, right? I think Amit. Or you people. So, okay, those who have not filled the form, I'll just reshare the form again. Just to know what you are interested in. One person asked me to, mm, tell the experience as a in corporate, how the things are. So we'll explore all these things, or explain you everything in the last couple of class, last like maybe next Thursday or Friday. Okay. So if you put all your queries, it will be helpful for me to take the next sessions. Right. Just check out the form and fill it, please. Okay. Okay, guys. Let's continue. So is my screen visible? I think it's visible, right? Those who are responding, say yes or no. Okay, great. Fine. So data structures. So introduction to data structure. Data structure means what? These are the fundamental components in CS, computer science, right? So we have to organize and store data in a efficiently. So imagine that you have your e-commerce data, or if you want to check out the Netflix things. So Netflix, Amazon, whatever, the data should be stored somewhere, right, for you to efficiently access it. So for that we have different kind of data structures. Okay. And the data structure provide a way to manage and manipulate data. Managing means, for example, if I want to access it, if I want to edit it, anything like my records, right, that's also possible using data structures. And they have operations like searching, sorting, updating. Let's say you go to Flipkart, right, you search there, but you want to sort by price, sort by rating. That's a realistic example, but we should have particular data structure for it to do it, and that's easily doable with different data structures. Okay. Now, understanding the data structures, their characteristic is very crucial for designing efficient as well as like efficient algorithm and building software systems. Okay. So next, let's just go to the data structures. Okay, so I have taken most commonly used data structures and some of the non-known data structures. So let's say arrays. What are arrays? Right? Array means a collection of elements stored in a contiguous memory location. Contiguous means if there is a memory location, they are stored side by side, right? Which helps us access the elements faster. And how do we access? Using indice or index. Okay. And arrays in Java generally are fixed size. There are dynamic arrays also, but generally arrays are fixed size. Inserting, deleting may be inefficient. Means, see, there are operations which takes a lot of time. These things we'll explore when you go deeper into any language. Okay. Next is linked list. Imagine train, right? Train has compartment. So compartment acts as a node, right? Node contains, so here elements contain data and reference to the next node, right? As a compartment is a node. There is a connection between every node, right? So linked list means all the nodes connected to each other, like a train, for example. How easy it is for insertion and deletion. Removing one node and attaching node is comparatively easier in array, sorry, in linked list compared to array. Random access is slow because accessing is always start from beginning, something like that. Okay. We have singly linked list, doubly linked list. Means singly means only from one way I can come, doubly means I can go and come back. These are the different types of list. Okay, arrays and linked list. Next comes stack. Stack means what? Keeping one above the other is stack. Like stack of plates, no stack of books, right? Though we can take it from middle, but stack means what? First in, last out, or last in, first out. So the person, the plate which we keep at the bottom, we can remove after removing all the plates. That's a stack. So a collection of elements with last in and first out behavior. The operations are either push it, like add it to the top, pop it, remove the top. So there are only two operations generally in the stack. Okay. Stack data structure means one above the other. The only thing we can do is either push at the top, pop at from the top. Okay. Until there are no more elements in the stack. Okay. Now it's generally used in all algorithms like passing expressions, managing function call. In detail stack, I'll explain later. Okay. Queues. The fourth thing is queue. Queue means what? You might have gone to theater, right? So there's a queue if you want to purchase a ticket. Those person who comes first will be served first. If you go to the famous restaurant, again there will be queue. First in, first serve. Okay. The operations here is NQ and DQ. NQ means add to the rare, rare means end, remove means DQ means remove from the front. We go to the line, if a new person comes, he is added to the last. If we have to go out means removed from the beginning. This is a queue. Okay. Train ticket, wherever you so you say queue is something like first in, first out. Stack is last in, first out. Okay. So where are we going to use it? Like scheduling, BFS, task processing. Scheduling means imagine there is something going on. I need to schedule, right? So based on the priority, I'll schedule. Everything will be in queue. Okay. Now next trees. Tree means what? It's a hierarchical data structure with a root node and branches leading to leaf node. Hierarchical means what? Imagine tree has root. From root there will be branches going on. That is a one of the data structure. Okay. So let's say our own hierarchy means our four ancestors. From there, it on the tree, like tree of our ancestors came up, right? Okay, that's a tree data structure. In the tree data structure, we have binary tree, n array tree. A lot of trees will be there, but mostly used is binary tree. Binary means maximum two children. For example, either have zero children or one children or two children. It's like binary where we can say binary tree real time examples. Binary. Okay, I'm not getting at this point, but I'll explain later. But here binary search tree means it's orders structure of efficient for efficient search and insertion. Binary tree, in that there is a binary search tree, BST. Generally binary search tree is asked, and we'll explain the BST also in the searching thing which we have maybe in Tuesday or Wednesday. Okay. Next comes graphs. Graphs means collection of nodes and edges. Means from one point to other point, right? Pair of nodes. So I said there are like four cities. So from city A to city B there is a road. From city A to city D there is a road, but not from A to C. So it means A to B, A to D we have, but not A to C. Then C to B we have, C to D we have. So that's a graph. Okay. So in the graph, vertices, nodes are called vertices. Like cities are like vertices. Edges means connecting between the cities are called as edges. And there are two things. One is directed graph, undirected graph. Directed means I know, okay, there is one direction from here to there, and undirected means there is no direction from anywhere we can have. Okay. Next, where it is really used, it's used in network modeling, social network analysis, routing algorithm. These are big things. Cool. And there's one more thing called as hash table. Hash table means key value pair kind of thing. So particular key, there's a value. So it helps in faster retrieval and insertion of data. Like if I want to insert data and retrieve, it's easy. So collision is handled easily. Like it's really helpful in chaining and open addressing. These are like different, but it's don't worry. This is a key value pair. So imagine you are uh, in college. So if you are given particular USN for particular key, then you will have your details. That's kind of a key value. Okay. Next, heaps. Heap is a specialized tree data structure, but heap sorting and a lot of things will come. Don't worry much on this at this point as a fresher, but still, when you explore more algorithms, right? Maybe when you cover the basics, then you can explore more on heap. So it's really efficient in retrieving maximum and minimal element. So we have something called as try. Try data structure. Try is used in searching, right? Google search and all. You get right when you do a Google search. If you type SA, then you'll get Sachin. That's called as try data structure. Lot of suggestions. You explore more on try. Okay. Union, find, disjoint set, skip list. So many things are there. You people can explore more on this. What these kind of what are these data structures? Where we'll use? Okay. Bloom filter, spatial data structure, self-balance tree, B trees. These are like a lot of data structure are there, right? Probabilistic, quad tree, oct tree, ABL tree, redback tree, slate tree, right? A lot of things will be. B trees means balance trees. Okay, fine. Okay, so this is about data structures. Today we'll explore more on array and strings. String is not there, but string is also one of the data type, but not data structure. Arrays, linked list, stack, and queue. Okay. So before we go to array in detail, okay, it's just a revision. Constant time, logarithmic time, linear arithmetic, quadratic, constant space. These are the time and space complexity. And I'm going to show the examples of it. Okay, let's explore more. Hmm. So let's just try exploring only time complexity. Okay. See, I have taken a lot of examples. 1 second, please. Sorry. Is my screen visible? YouTube. Yesterday video is there on YouTube. You can just check. Sarfraj, it's there. Okay. Now let's see here. Okay. Now which one should we go? Let's go with constant time. Constant time example. Okay. Here we go. Just try to understand this. Hmm? So just check this. This is already I have given you same similar example in here, right? Search. Okay. This is also same. Constant time means, see, I try to use array of index. See, using this accessing is only once. Okay. Just try to check this example. What we are trying to do, we are trying to check whether in this array number two or like index. 1 second, wait. Okay. Fine. See, I have written a function which gives me a index number at particular index. For example, this is 0, 1, 2, 3, 4, 4 index, right? So if I say, hey, get me an element at index 2, then it should give me 3. Correct? Let's run this. So it is giving 3, right? So if I ask, get me an element at index 4, then it should give me 5. Let's just explain this, explore this. It's giving me. If I say, hey, give me at index 7, then it should throw error saying that, hey, index out of bound. Index out of bound means you are searching in an array where maximum index is 4. This is at 0, 1, 2, 3, 4. Starting from 0 to 4. But length is 5. Okay. And if I give 0, then the output will be 1. Clear? Cool. I'll just explore. This is time complexity for 1. Now, let's say logarithmic time. Log n. Where is logarithmic? Log. I think I might have taken book example. No, book is of no dictionary. See, I'll explain this when I go with the searching and all. Okay, but for time being, just imagine this dictionary is a sorted one. So when I ask this program or function binary search, hey, can you find me a string which is date? Searching. So what it does, it goes here, okay, and with this logic, it divides the search array by two, by half, and it checks whether the date is available in middle. If there are six, it will compare with cherry, means I mean the third one. If there are seven, it will compare the middle one. That's the logic here. So I'll just show you what's happening. I'll just debug. This explanation will do it in the upcoming classes. I'll just show you debug and show you the time complexity. Imagine here. So at this point, I'll try searching. Okay. It compared. So now the mid is 2. So it just try to compare here. Okay. It's not working. Then again, it goes. See, here there is some comparison going on. What it says is whether it's in the left or right. I'll try to search like that. So when I compared here, I got no, it should be here. Then I started searching there. Next one. Okay. Something like this. Then at that end, I'll get at which index it is the data is here. It's at 0, 1, 2, 3 at index 3. So I got to know, hey, I found the string date at index 3. So imagine data. If I do this, if I try to run, it will say it's not available. Index is -1. -1 means it is not available. Okay. This is a binary search for log and time complexity. Okay. But what happens is, okay, if you want to get this right, you have to go here, GitHub. Okay, I'll just share here also code. But if you go here, if you click on this day 3 here, then this time complexity. Oh my god, I'm really sorry. Some work is going. I'm really sorry, guys. Like I don't know, some work is going on above. This is a time complexity which you can get. Okay, just try to open this. I'll try to share this in the YouTube also. You can just check it out. You can try along with this. Just what you can do is you go to online compiler. Okay, go here, and what you can do is this is the main method. Don't do anything. Just copy the code inside this class. Don't worry about all other things. Okay, put it here. What's happening? Okay, its compiler is taking time. Okay, see here. I ran, it should give me the result. You people can just check this. Just whatever is there in the class name. If I have class name by dictionary example, just everything inside you put it in the hello world and it will run. Okay, let's take one more example, constant time example. So what I'm doing, I'm taking everything inside this except this last curly bracket and this one and pasting it here. One second. Saving your time. You people can explore more. You can write your on your own also. See, I've written it. I'm running it. And I could see the output. At index 1, it's there. If I, sorry, searching, right? If I want at index 3, what is the value? It should be 4. See, I got this. So you people can try this also. Okay. So again, let me just. I'll try to share these things in YouTube. Or I can send it. Not able to. Okay, someone watching, someone who is having access, please share it. Okay, I'm not able to share. Just share these two things, one, and then these programs. We'll continue. So, are you able to see my screen? Just let me know. You see my screen? Okay, great. Okay, so the same way you can just check cubic time simulation. See here, if I want to create or like read this, right? Matrix multiplication, something you people know. This is n cube time complexity. Hmm? And then n square at least bubble sort. N log n is linear rhythmic. You can just explore more here. Okay, merge sort. These are just example. We will be learning this in coming classes, but if someone is interested, then definitely go and explore more here. Okay, this is also a website simulation. Something is there. Cool. And coming to space, again, constant space means just here. What's happening? I'm just using one variable to add two numbers. This is like constant. This is constant space. Clear? Linear space. If I want to create a duplicate array, then if array is of 5 items, then I need a array of space 5. If array is n, I need array of new array of space 5. So the complexity is linear. Like how many items are there? That many. Big O of n space. Clear on this? Any doubts on linear space complexity? Just explore more. Maybe we'll discuss when I come to this. Okay. Logarithmic space, how it's all power of two, how power of two calculate this. This is basically for recursion. Recursion and all, yeah, different one, but we'll learn that maybe in upcoming, like maybe in future classes when we'll go advanced Java or something. Okay. Quadratic space, just check this quadratic, creating a matrix. If I want to create a matrix, matrix means what? Two-dimensional array or three-dimensional array. So based on that, if it's a two-dimensional, it's n square. If it's a three-dimensional, n cube. Clear? Okay. So these are the examples for this quadratic space, linear space, all the things. How do you calculate? So probably Monday I'll come up with some examples or some assignments where you people can calculate time complexity. Okay. Now see, this is just more detailed way about arrays. Arrays means what? Collection of elements, each defined by an key index and key. They store data in a contiguous memory location. Indexing based on the index, like zeroth index to the n minus 1, they are stored. Arrays have fixed size generally. Homogeneous means same type of elements. Okay. If I put, if I say fruits of array, then generally keep fruits. If I say numbers, keep numbers. Memory efficiency, it's easy to access. That's why it's memory efficient. This is one example I have given here. This PPT also will be available for you if you are subscribed to the XLR. Okay, this program, if you are subscribed, then definitely this presentation will be available. Just check this, how I create an array, third element. If I want to access third element, zero, second index, because first element is zeroth index. Updating means I can update here. Iterating means this is the way you can iterate using for loop. If I want to update some element, I can do it. Okay, we can explore more on this. You can just try here. Let's say if I want to go and try something. See here. This is array. Okay. I want to do this two and add the this 3 will be replaced by 23 now. That's it. This is one of the way to update it. Okay. Iterating is for loop. Again, we have seen this. Let's say real time usage in world. This is a lot useful for you all. Just listen here. Hmm? In your interview, they'll say, "Hey, give me a real example of array." Yes, array is the collection of similar data types. Generally, you're right. Okay, so see here. This is they store the things and homogeneous. Homogeneous means same type. Okay. Now, in interview, how you'll make impression? You have to you like if they ask you array, they should say you should say like, hey, we are using arrays in databases because we can organize and represent data in database system like rows and columns. Okay, in array, particular row, particular column that will be used in arrays. Image processing, you people have heard, if you're from AI world, you say that this you watch a lot of movies, right? Image processing, a lot of things happen there. Okay. Matrix in graphics, like 2D graphics. So we have a lot of design. So when we have a software, we make a lot of designs, 2D designs, 3D design. That printer, we'll have that, and our bike, our car, that printing, right? 2D, 3D, that's all comes with this, something like this. Time series data. Time series means stock prices. If someone is checking on the stock, so we say some stock is high, low, based on the stocks, right? Our pricing, inflation happens. All these things we can store and show to the users. Okay. Simulation modeling. Simulation means if you people are okay. Imagine I want to simulate the marks of a student, so I can just store them in array and show. If this is the case, students can be represented like this. Okay. Scientific computing, operating systems, embedded systems. So these are a lot of things. Scientific, you can just say engineering, bioinformatics, physics, right? Operating systems, kernels. If you know OS, it's kernels, control blocks, file descriptors. A lot of things are there. Embedded system, EC people will know there. Sensor data and controlling hardware. You use arrays. Anyone is from EC here who has used array? in embedded things? Anyone? Nobody? People are joining now. Okay, great. Nobody's from EC here who have used arrays in embedded systems? Okay, cool. Now we'll just understand linked list. I told you linked list means something which is connected via link using node, right? So what is by definition? A linked list is a linear data structure. Linear means trained like one by one, not like tree, like one has two child. One compartment will be connected to only one compartment. That's a linear thing, right? Every compartment is node. So here definition says a linked list is a linear data structure where elements which are known as nodes are connected to other nodes via pointers or references. Arrays are not like that. They are contiguous memory locations. Okay. Each node has data and a reference to the next node. Okay. The last node points to null because after last there is nothing, which means that's the end of the list. List size can be dynamic because I can append at the end. So if there are only one node and I can add one more node saying that node dot next is new node. Again, third node. So let's say node one dot next is node two, node two dot next is node three dot next is node four. This is a list. Okay. So they can adjust, we can remove. Singly means singly linked list, doubly linked list, circular linked list. These are generic, mostly used types of linked list. Okay. Singly means one node is pointing to other node, but there is no reverse. A is pointing to B is pointing to C. There is no reverse. Doubly linked list means A is pointing to B is pointing to C, but C can point to B can point to A. But A cannot point to at the end. Like circular means A to B to C to A. Circular linked list. That's it. Okay. So general operations are insertion, deletion, traversal. Insertion means I want to add one node. Deletion means I want to remove. Traversal means traversing through the linked list. Okay, I think. Okay, let me take 2 minutes break. I think some small work is going on. But meanwhile, you can ask me the queries here. I'll be on mute. Okay, I think I hope they're not going to start the work again. Anyways, are you able to see my screen? Someone respond yes, please. Waiting. Okay, cool. So, linked list in real time usage, right? Dynamic memory allocation. You might have heard, right? So, I don't know what is the size of data, then I need it. Undo redo functionality. Just imagine we have editor. Oh my god. I'm sorry, guys. I'll wait for a minute more. Okay. See, the work is still going on. I'm not sure. Really sorry on this, but let's just continue. See, undo redo functionality. You might have used it, right? So this is also, you can do it in linked list. Task management, right? That's also available. Symbol table in compiler. A lot of things are there. Music video playlist, right? See, this is a realistic, right? Music video playlist. What happens? I'm audible. Okay. Hope I'm audible. Am I audible? Yes. Hello. Yes, I saw in YouTube people saying that it's not audible. Yeah, okay, cool. So, music and video playlist, just see as linked list, right? If I want to go to the next and previous videos, that's also available. Or randomly, I can scroll and go to any video, right? Generally, music playlist is a real good example of linked list. File systems, file also, I can say one from one, folder to folder, and come back, all those things. Dynamic caching, graph algorithm, lot of things are there. Okay. Next, stack means what? Stack is a linear data structure which follows last in first out principle. So these are the interview questions: array, linked list, stack, queue. Generally, people ask interview questions on this, at least for freshers. Okay. So what it means? It means last in, first out. Someone who comes last goes first. Okay. And what operations we have? Push, pop, peek is empty. Push means, okay, add to the top. Pop means remove from the top. Peek means just check out who is there at the top of the list. Top of the stack. Is empty means just checks, okay, it's empty or not. Okay, implementing stack, either I can use arrays or linked list. So using this, we can implement. Okay. Okay, let's just say real-time example. Function calls, a function calling other function. So this is next level of thinking. Recursion is something which generally one of the interview question which you people can learn if you want to go to the next level. Expression evaluation, undo mechanism in software, web history, web browser history. Just check it out. So in browser, right? If I go to the back, no, history, right? So uh, they'll be kept one another. That's a web browser history. Okay. Then memory management, expression matching, task management, postfix. These everything can be done in stack using stack. Okay. Queue. But these things you can explore or stack things, stack programs. I'll get you on Monday some programs. I'll show you how it can be done. Cool. Next, queue. Queue means what? Queue is a linear data structure. Same thing. Linear means what? One behind the other, like only one at once. At once, like no, there is no direction. Right from A, I can go to B, and then again something like that. Okay. Graphical means or tree means non-linear. Okay. So it's a linear data structure which follows first in, first out principle. Elements are added at the back, rear, and elements are removed from the front. So operations we call like NQ, DQ, front, rear is empty. NQ means add to at the back. DQ means remove from the front. Front rear means just check who is in the front, who is in the rear. Is empty just to see whether queue is empty or not. I can do implementation using arrays, linked list, or circular queue. Okay. No. Queue. Simple. See, in operating system, right? So I can keep tasks and they're in queue. They're executed in queue. Even in the theater, whatever I said, no, same example. But in the technology voice, task scheduling on in operating system. If in operating system, if I add task, they're also done in first comes first service, first come first serve method. BFS in graphs, order processing in restaurant. Restaurant also, right? The first customer is served. That's how it is. Okay. See, if you learn, right, when you have go with like 2 years or 3 years experience, you will have to code on something like message in queue, right? In communication system, message queue is something which comes up where you have to handle a lot of data, a lot of API, all those things. Buffer in networking, buffering, right? So what happens? YouTube buffering, that's also queue. So which is the next fragment? Which is the next fragment? That's how we'll be exploring. Print spooling, browser history, again same thing. You can use Q also. Okay. So yes, that is for today. But before I end, I just wanted to show some programs on array as well as strings. Okay. So check this. This program, what it does, it reverses an array. It checks for duplicate numbers. This one checks for average. These are the three programs. Okay. Let's just check this. Hmm? Only this one program. Hmm? Reversing an array. Reversing an array means what should be the output? The array should be like this. No, the output should be. I'll just tell you, output should be like this: 5, 4, 3, 2, 1. This should be the output, right? How can I do? I should just get the first element and put it at the last, second, last but one, like this, right? What can I do? How can I do? That's what we have to check it out. So what we can do? Let's just do the logic here. What I'll do? I'll just try to debug. I'll show you everything how it can be done. Okay, just check here. So what I did, I have taken a empty array of length same as this. So what I'm doing here, I'm starting from 0, I equal to 0. I made j is number length dot minus 1, which means 4. Okay, then I is less than numbers length, I plus plus j minus minus, which means I have to decrease j. Okay, so what I'm doing, I'm putting in 0th index, the last element of array. Okay, I'll just explain here now. Just check it. Okay, one second. Let me debug. Hmm? Okay, just check here. What is the value of I here? I is 0, j is 4. J is 4 means in the numbers of 4, fourth index 5 is there. So what in the new array, 0th index, what I'm adding? Just check now. Now in the new array, at the 0th index, we have 5. Now, and I do next, 0th index, what is there? We have 4. The next index, first index 4, second index 3, then 2, then 1. So basically, the logic is straight. So what I'm doing, I'm creating a new empty array, and 0th index, I'm putting it last, which is length minus 1. Then first index, length minus 2. Second index, length minus 3. Things like that. I kept on decreasing j, increasing I. So what happens if when I is 0? Okay, I'll just explain here. Just check this logic. When I is 0, j is 4, means last one. J becomes 4. When I is 1, j becomes 3. When I is 2, j becomes 2. When I equal to 3, j becomes 1. When I becomes 4, j becomes 0. Okay, this is the basic logic. So with this logic, we'll be able to get a new array which is sorted, which is very simple. I'm not doing in place sorting. I'm creating a new array with this new values. Any queries in this? What's happening in this logic? Let me just check the chart. This is mostly asked in interview, right? Most of the questions are like, okay, please reverse the array and give me. This is the logic behind that. Okay, this above logic does the same thing. check this. Did I share? Okay, I think I had not shared complete screen. Oh my god. Okay, I think I had not shared the complete screen. Sorry. Mhm. Okay, oh my god. Sorry, guys. Okay, let's just. I think now you are able to see the screen. Can you see the program screen now? Yes, okay, cool. Okay, just check. I want to reverse this array. Okay, I debug. Just check this code. Now, at this point, I okay, let here. I is 1, J is 3. So we are swapping here. Okay, I'm putting the item at the third index to the first index of new array. Just check the reverse. Now 5, 4, 5, 3. Look here. 5, 3, 5, 2, 5, 1. Okay. So now the reverse is like this. Now at least you saw that. Okay. You can ask me questions here, but I thought like initially I had shared screen. Did you get this basic logic? When I was 0, I made J as 4 because at the fourth index, whatever I have, I want to put at the zeroth index. At the third index, what I have, I want to put at the first index. At the second index, what I have, I want to put at second index. At the first index, whatever I have, I want to put at the third index. At the zeroth index, whatever I have, I want to put at the last. This is the logic here. You please, you can just try out and see. Okay, just show you here, maybe here only. Look here, you can see the reversed one, right? So we can just add 6, 21, 12. Okay, now let's see here. Can see, right? 12, 21. It just got reversed. Clear? I'm really sorry. Like I missed that. Did you get this? Did you try it? Okay, that's really clear. Great. So the same way we have other programs like whether numbers duplicate. Duplicate means I'm just comparing. Hey, just compare I with J means two numbers I'm taking. I'm comparing whether any duplicates are there. If duplicates are there, I'll say duplicate found. Okay, that's one. Average means I'll add and then divide by length. If I want to find the average of a number, then what I'll do, I'll just do a for loop. I'll add them and divide by numbers length. That's the average. Removing duplicate means I'll move all the duplicates to the end and I'll just take the unique characters here. That's it. These are the array problems. You can go to this GitHub and explore. Okay, you just check this. You'll get it. Day 3. Hmm? Okay, day 3. Java array programs. You'll have everything. Now let's explore the next one. String problems. String problems. Okay, this array and string. Generally, array and strings are focused more in interview. Okay, just check that out. Palindrome, counting vowels and consonants, all these things. Reversing a string, string, same thing. Take this, reverse it. Okay, I can use append method or character at, see, just check it. I'm taking character at last and then adding it to the string. Like I'll take G first and then add N first, I'll add I, M, like this. I'll keep on getting the last one add. So when I do this, I'll get G and something something at AV GA, something like that. Okay. Substring occurrence. This is also one of the interview question. For example, see, Java is a popular programming language. How many times this keyword substring have occurred? I can just check out here with this code. Okay, I'll just run this and show you what could be the answers. You'll have a lot of answers. Reload. See, vowels are 6, consonants are 11, reversed 1. Hmm? Occurrence of Java is twice here. Yes, that's it. Okay. Now this is the only code which I had not pushed. I'll push it now to the GitHub. You people can explore that. Okay. Any queries? You have 10 minutes. You people can ask anything. Or you can also check out if you have faced interview, what are these the generic things on array and string people ask most or not. That also you can just let me know. And please try to fill this form. That will help me. Okay. The form I shared at the beginning. Based on this, I can prepare my content, next content. This is for everyone, like no, nothing to do with computer science. Anyone can do. So no questions. So let's see if anyone from YouTube is doing that. No doubt. Oh, really? Thanks, Ashish. Great, but just go through that GitHub and try to explore more on that. Okay, if you just type this, you will get it. Yes. You'll get this. Okay. Okay, then no more queries. We can just wind up. From YouTube also, if anyone is there live streaming, you people can let me know. There are 16 people, I believe. No? Link of form. I think, oh, that form. Okay. Can you please share this form? I'll get to know more about the students who are joining. Please. Can you share this, please? Who are Chandana, do you mind sharing this to the students, please, in the YouTube? No, not that one. Not the attendance one.
Okay, then which form, Lakshmi?
No, no. Just now I pinged you, right? That is for the form where I would like to know about students, right?
Okay.
About where. So I'll just show you which form is that. I'll just show you. This is the form.
You sent me now that one only, no?
Yes, yes, yes.
Yeah, okay, I'll share.
And that's it. Cool. Thank you. And also, if you can share this GitHub also, I don't mind. Just put it in the chat. Okay. Those who are checking, if you want, you can just check this GitHub code also. Okay, I'm just looking. Okay.
Sure,
The form.
I'll send this as
Yeah, yeah, I'm just checking out. Okay, this is great. Thank you. Okay, at least you can tell me how was it, what different you found, maybe next 5 minutes, and any queries, anything you have. 5 more minutes, we can ask anything. If If you have any questions, like, okay, it's how to make program interesting, or if you have anything like you're scared of programs, you can ask me. I'll answer any of your questions related to programming. Chat here, you can send the chat. Okay, if there are no questions, then we can wind up and meet on Monday with real programs, and I'll have like 30 minutes of live coding session where you can code along with me, or you can practice. Okay. Okay, then all of you, whoever, I think Afify is there. So many people have responded. Thank you for making it interactive, because if you all, I could, just speak more. Like Vaishnavi, Amit, Anjali is there. So I think Om is there. Cool. Yeah. Who else? Guru Devi, Mamta. Okay, guys. Okay, folks. Thank you all. Okay, I got one more message, right? Thank you. Thank you, Adit. Thanks a lot. Appreciate it. Yeah, I'll be there for here. Couple more minutes, then I'll wind up. If any queries, just post it. Thank you. Have a happy weekend and enjoy Deepavali. Happy Deepavali to you all. Keep smiling, keep coding. Tick tick one, tick tick two, tick tick three. Thank you, Afifa. Thank you. Motivates me, motivates your messages are motivating. Thank you. I'm happy to hear that it's helping you. 5 more days, we'll learn a lot of algorithms, like, searching, sorting, dynamic programming, all those things, recursion, lot many things you'll learn. Okay, then. Thank you. We are winding up. See you on Monday. Happy weekend. Enjoy.
Yeah, thank you, Lakshmitan. Guys, hope you enjoy the session. And everyone, happy Diwali. And we'll meet you on the Monday.